This is a quick review of the normal distribution chapter, central limit theorem, and confidence interval using Statcrunch. Question 1. The scores on a national certification exam are normally distributed with the mean of 750 and standard deviation of 80. What is the probability of randomly selecting a student who has a score less than 600? So let me show you how to do that using Statcrunch. So you go to Statcrunch, you go click on Stat, Calculators, Normal. You enter the value of the mean, which is 750. You enter the value of the standard deviation, which is 80. And he wants what's the probability of selecting a student who scored less than 600. 600 right here. And here's the answer, 0.0304. What is the probability that a student score between 700 and 850? So between 700, you need to click on between and put 700 here, 850 there, and hit compute. Not only it's going to give you the answer, but it's going to shade the region under the curve. So it's 0.6284. C. What is the minimum score a student needs to be in the top 10% of test takers? Now, in this case, he's not asking for the probability. He's given us the probability. He said it's the top 10%, so it's 10% shaded toward the right, and he wants the X value. What would be the minimum score that someone need to score in order to be considered in the top 10%? So let me show you how to do this using. So top means it's an area to the right, so you need to change the less than to greater than. And then right here, guys, because it's a probability, the probability should be in this box, in this field right there. This field here is reserved for the X values, and this for the areas for the probability. So 0.10, 10%. And look, this one becomes empty, and this is what we're looking for. We're looking for the X value. So a student would need to score at least 852.5, let's say 853, in order to be considered in the top 10% of scores. So anything that is 853 or more will be considered a top 10%. Okay, next question has to do with the central limit theorem. A company manufactures light bulbs whose lifespan is known to have a mean of 1200 hours and a standard deviation of 150. We select a random sample of 40 light bulbs. Once you have a sample involved, so it's going to be the central limit theorem, and the question is going to be about the sample mean. What is the shape of the distribution of the sample means? As you know, according to the central limit theorem, the shape of the sample means will be approximately normal bell-shaped. The mean of the sample means will be the same as the original mean, which is 1200. But the standard deviation of the sample means will not be 150. It will be 150 divided by square root of the sample size, which is in our case 40. So it will be 150 divided by square root of 40. Which I have done the calculation, guys. 150 divided by square root of 40 will be 23.72. So to answer part B, the mean will be 1200 and the standard deviation will be 23.72. C, that's very important question. What is the probability that the sample mean lifespan of the 40 bulbs is greater than 1250? So we're going to go to the normal calculator and show you how to answer this question. Okay, we are back to the normal calculator. You need to change the mean. It's 1200 in this question. But the standard deviation, since this question is about the sample mean, it's not 150. It's 150 divided by square root of 40, which I showed you is 23.72. And he wants us to find the probability of the sample mean being greater, I believe, than 950. or greater than 1250. So right here, 1250. This simple x, guys, should be x bar here, x with the horizontal line on it because it's about the sample mean. But the Statcrunch doesn't allow us to change the x, it's fixed. So we pretend like it is an x bar here. Compute, and the answer is 0.0175, which is 1.75%. Remember, any probability that is less than 5% is considered unusual. Anything that is 5% or more is considered usual. Okay, next question. We have this question right there. The amount of milk dispensed by a machine into containers normally distributed with the mean of 128.5 ounces and a standard deviation of 0.2. The company wants to set a low fill warning at the amount where only 1% of the containers have less milk than the amount. What is the minimum amount of milk in ounces? So again, here he's giving you the probability, and he wants the x value. So let me show you how to do that in Statcrunch. And he says it's 1% of container have less milk than the amount. So less, it's toward the left. All right. So part B, what to fill amounts symmetrically around the mean contain the middle 95% of all dispensed milk volumes. So he's giving you the area in the middle, which is 95%, and he wants you to find the x value toward the end of this area and x value at the beginning of this area. And how do we do that? So you just go to between this time. And he says the area is 95%, so you just put the 0.95 right here. And now, guys, you're gonna notice two values of x, one toward the beginning of the 95% and one toward the end. And these are the two values. One is here and one is there. You can read them. The first one is 128.108 ounces, and the other one is 128.892 ounces. Another question. The scores on a standardized aptitude test are normally distributed with a mean of 500 and a standard deviation of 100. A university only wants to admit applicants whose scores are in the top 15% of all test takers. What is the minimum score an applicant needs to achieve in order to be eligible for admission? So he gives you the mean, which is 500, standard deviation was 100, and he wants what score should one get in order to be considered a top 15%. Let me show you how to do this. So the mean is 500, the standard deviation 100, top means greater than, and 15%, guys, should go here. This box is reserved for the area 0.15, and here you go. So a student should score 603.6, you can say 604, in order to be considered a top 15% student. Now, another thing here, if he asks you to find, for example, a probability of z greater than 1, he won't give you the mean and the standard deviation, because in the case of z, the mean is 0 and the standard deviation is always 1. So probability of z greater than 1 will be this. Or if he asks you to find the probability of z less than 0.75, you just go here. When it is about z, guys, make sure that the mean is 0 and standard deviation is 1. So less than 0.75. And here you go, compute. Let's say he asks you find the 75th percentile. When he gives you the percentile, that means he's giving you the probability, he's giving you the area to the left, which is 0.75. So what you do in this case, you just go here and put 0.75, and you're going to get the z-score. The z-score is 0.67. If he says find the 90th percentile, you just change this one to 0.90. And here you go. The 90th percentile is z equals 1.28. So this is pretty much what you need to know about normal distribution and the central limit theorem.